morning. So, today we are going to talk about how to play with the screw or the conveyor speed inside the decanter centrifuge. Mainly, this video is for, let's say, you're juggling with uh, making a moist salt or cleaner centrate, and the variable that you have considered to change is the conveyor speed. So so there is a term called uh, differential speed, or it is also known as relative speed in the decanter centrifuge. So let's say we want we are getting a recommendation from the vendor that we want to run this machine at a higher differential speed, so as to get a higher moisture, and or our requirement is to get the cleaner centrate. We care more about clean centrate than making a dry salt. So what are our options? We if we need that type of product, then our option is to go with a higher differential speed. uh, what is differential speed? So differential speed is basically the bowl RPM. Let's say the bowl is rotating at 2000 RPM minus the Sunwheel RPM. It is also known as, in short, not directly but indirectly as a conveyor RPM. There is some conversion to it, but for now I'll stick to the Sunwheel RPM as the nomenclature, divided by the gearbox ratio. So, so let's take an example here. Uh, let's say we are running the bowl RPM at 2000 RPM. Sunwheel speed is 300 RPM and the gearbox ratio is 80. What will be the differential speed? So, if the conveyor motor is running in the forward direction, then this formula is applicable, that is bowl RPM minus unwheel RPM divided by the gearbox ratio. So that will give us 2000 RPM minus 300 divided by 80. That will be like 21.25 RPM. Now note that this is the maximum. Why do I say that? Because let's say if I am running this at 2000 RPM, the bowl RPM, and let's say I increase the Sunwheel RPM speed to, let's just say, 1500. So divided by 80 will be like 500 divided by 80. So that will be like 500 divided by 80, and that's 6.25. So you can see that it goes to a lower differential speed if we are increasing the Sunwheel RPM. So if we continue to run the conveyor motor in forward direction, the least RPM we can go is 6 point differential speed, sorry, is we can go is considering 1500 as maximum RPM on the conveyor. Then 6.25 RPM is the minimum differential speed, and 21.25 is the max differential speed. So we are kind of stuck over here in between these two differential speed. Can we go higher on differential speed? The answer is yes. How do we do that? So there is, if we run the conveyor motor in reverse direction, then our differential speed becomes bowl RPM plus the Sunwheel RPM divided by the gearbox ratio. So let's stick to the same bowl RPM 2000, and Sunwheel RPM is in the reverse direction 1950, and gearbox ratio is the same 80. The differential speed becomes 2000 minus, actually plus 1950 RPM, and it becomes divided by the gearbox ratio, it becomes like 49.4 RPM. Now let's say we this will be the, I would say, the maximum when the conveyor motor is in reverse direction. Let's go with the example of we run the sun wheel in at a lower RPM, that is 300, still in reverse, but at 300 divided by 80. So that will be 2300 divided by 80. So that comes out to be 28.75, 28.75 RPM. So this will be the minimum. So note that when we are running in the reverse direction, the minimum is 28.75 RPM as a differential speed, and 49.4 RPM is the maximum differential speed. So this is the range when we, in this particular case, when we are running in the reverse direction, and this is the case when we are running in the forward direction. Uh, this configuration is more and more helpful when we are looking for a lower moisture content in the salt. So we run it at a lower differential speed, and but it comes with its cons that it might have more solids in the centrate. I mean, it's a possibility. That's something then we have to play around with the template. So, so this is more in context to the conveyor motor direction and how it will impact the differential speed, which will eventually impact the moisture content in the salt. Thank you.